Hi, good morning to each and everyone. My name is Shirley Barcoma, CHS ICT Teacher of Elysium Alabang. My topic is all about implementing the model-driven architecture. I will be explaining the MDA approach in terms of major concept, the premises, and the goals which driven its adoptions. The Object Management Group was formed as a standard organization to help reduce complexity, lower cost, and hasten the introduction of new software application. One of the major initiatives through which the OMG is comprising this goal is by the promotion of model-driven architecture as an architectural framework for software development. This framework is built around a number of detailed OMG specifications, which are widely used by the development community. In 2001, the OMG adopted the model-driven architecture as an approach for using the models in software development. Its three primary goals are portability, interoperability, and usability through architectural separations of concerns. One fundamental aspect of MD is its ability to address the complete development life cycle, covering analysis and design, programming, testing, component assembly, as well as the deployment and maintenance. MDA itself is not a new OMG specification, but rather an approach to software development which is enabled by existing OMG specifications such as Unified Modeling Language, the Meta Object Facility, and the Common Warehouse Meta Model. Other adopted technologies which are of interest are the UML profile for enterprise distributed object computing, including its mapping to EJB and the COBRA component model. With the new platforms and technologies constantly emerging, MDA enables the rapid development of new specifications that leverage them and streamlines the process of their integrations. In this way, MDA provides a comprehensive structured solutions for application interoperability and portability into the future. Precise modeling of the solution domain in UML provides the added advantage of capturing its inherent intellectual property in a technology neutral way. As illustrated in the diagram, the OND envisions MDA to encompass a full range of pervasive services, which are commonly found in modern distributed applications. Before MDA and related concepts can be explained and analyzed, a couple of basic concepts have to be defined. One here is the system itself. We have to take note that the context of MDA is the software system, either pre-existing or under constructions. We have two different system notions exist, the theological and the ontological system notion. The theological system notion is about the function and the external behavior of a system. This notion can be visualized with a black box model. The theological system notion is adequate for the purpose of using or controlling a system. The ontological system notion on the other side, can be used for building or changing a system. It is about the constructions and operation of a system and can be modeled with a white box model. Both the theological and ontological system notions are relevant for designing a system. In other words, both the functional and constructional perspective of a system are relevant. In software, the terms functional design and technical design are often used to refer to these perspectives. A model is a form specification of the function, structure, and behavior of a system with a given context and from a specific point of view or reference point. A model is often represented by a combination of drawing and text, typically using a formational notation such as unified modeling language, augmented where appropriate with natural language expressions. A specification is yet to be formal when it's based on a language that has a well-defined semantic meaning associated with each of its constructs. To distinguish it from a simple diagram showing boxes and lines. It is formalism, which allows the model to express in formats such as XML in accordance with a well-defined schema. So, to emphasize, a model of a system is a description of specification. That system its environment for some certain purpose. A model is often represented as a combination of drawings and text. The text may be in a modeling language or in a natural language. Model-driven describes an approach to software development whereby models are used as the primary source of documenting, analyzing, designing, constructing, developing, and maintaining a system. The architecture of a system is a specification of parts and connectors of the system, and the rules of the interaction of the part using the connectors. Within the context of MDA, these parts, connectors, and rules are expressed by a set of related models. A viewpoint on a system is a technical for abstraction, using a selected set of architectural concepts and constructuring rules in order to focus on particular concerns within that system. Here, abstractions is used to mean the process of suppressing selected details to establish a simplified model. The architecture of a system is a specification of the parts and connectors of the system, and the rules for the interaction of the parts using the connectors. Within the context of MDA, these parts, connectors, and rules are expressed via a set of related models. A viewpoint on a system is a technique for abstractions using a selected set of architectural concepts and structuring rules in order to focus in particular concern within that system. Here, abstraction is used to mean the process of pressing selected detail to establish a simplified model. MDS specified three default viewpoints on the system: computations independent, platform independent, and a platform specific. The computation independent viewpoint focuses on the context and requirements of the system without considerations or its construct or processing. It focuses on the environment of the system and the requirements for the system. The detail of the structure and processing of the system are hidden or yet determined. The computation independent view can be compared to theological system notion. platform-independent viewpoint focuses on the operations of the system while hiding the details necessary for particular platform. A platform-dependent view shows the part of the complete specifications does not change from one platform to another. A platform-independent view may use a general-purpose modeling language or a language specific to be the area in which the system will be used. The platform-independent viewpoint can be compared to the ontological system notion. An ontology is implementation independent by definition. A platform-specific viewpoint augments a platform-independent view with details relating to the use of a specific platform. It combines the platform-independent viewpoint with an additional focus on the detail of the use of a specific platform by a system. A platform is a set of subsystems and technologies that provide a coherent set of functionality through interfaces and specified uses patterns, which any application supported by that platform can use without concern for the details of how the functionality provided by the platform is implemented. In principle, a platform is placed to launch software on. Example, platforms of operation system, the Java virtual machine, runtime libraries of the programming language, databases, user interfaces, and middle solutions, etc. Platform, platform independence is a quality which a model may exhibit. This is the quality that the model is independent of features of a platform of any particular type. Like most qualities, platform independence is a matter of degree. So one model might only assume ability of features on very general type of platform, such as remote, invocation, while another model might assume the availability of a particular set of tools for the Cobra platform. Likewise, one model might assume the availability of one feature of a particular type of platform, while another model might be fully committed to the type of platform. A Platon model describes a set of technical concepts representing its constituent elements and the services it provides. It's also specified constraints on the use of these elements and services by other parts of the system. Model transformation is the process of converting one model to another within the same system. The transformation combines the platform-independent model with additional information to produce a platform-specific model. An implementation is a specific that provides all the information required to construct a system and to put it on operation. It must provide all the information needed to create an object and to allow the object to participate in providing an appropriate set of services as part of the system. MDA specified three defaults model of a system corresponding to the three MDA viewpoints defined as while ago. The MDA models include computation independent model, platform independent model, platform specific model. These models can perhaps more accurately be described as layers of abstractions, since within each of these three layers, a set of models can be constructed, each one corresponding to a more focused viewpoint of the system, user interface, information, engineering, architecture, etc. Computation independent model. It also often referred to as a business or domain model because it uses a vocabulary that is familiar to the subject matter experts. It represents exactly what the system is expected to do. but hides all the information technology-related specification to remain independent of how the system will be or currently is implemented. The CIM plays an important role in bridging the gap, which is typically exists between this domain expert and the information technologies responsible for implementing the system. In ang MDA specification, the CIM required should be traceable to PIM and PSM, construct the implement them, and a vice versa. A computation-independent model is a view of a system from the computation-independent viewpoint. The CIM does not show details of construct of the system. The CIM is sometimes called a domain model, and a vocabulary that is familiar to the practitioners of the domain is used its specification. It is assumed that the primary users of the CIM is the domain practitioner or business consultant. The user of the CIM does have to knowledge about the models or artifacts used to realize the construction of application applying to the requirements defined in CIM. The CIM specify the functional or external behavior or a system without showing constructional details. The CIM plays an important role in bridging the gap between the domain expert or the business expert and expert of the design and construct the system or IT expert. Platform independent model exhibit a sufficient degree of independence so as to enable its mapping to one or more platforms. This is commonly achieved by defining a set of services in a way that abstract out technical details. Other models then specify a realization of these services is a platform-specific manner. A platform-independent models is a view of system from the platform independent viewpoint. The PIM exhibit a specified degree of platform independence so to be suitable for the use with a number of different platforms of similar type. A PIM describes the construction of a system on ontological level, meaning that the construction of the system is specified without implementation details. The ontological model of a system is defined as something is a system is the only if it has the next properties. Composition, a set of elements, some category, physical, biological, social, chemical, etc. Environment, a set of elements of the same category. The composition and the environment are disjoint. Production, the elements in the position produce things that are delivered to the elements in the environment. Structure, a set of interaction bonds among the elements in the composition and between these the elements in the environment. An important characteristic is the category to which the elements of a system belong: physical, biological, social, chemical, etc. In the case of MDA, we start with a model of enterprise. By model, translation is a try to convert this model into a model of a software system. Platform-specific model combines the specification in the PIM with the details required to stipulate how a system uses a particular type of platform. If the PSM does not include all of the details necessary to produce an implementation of that platform, it is considered abstract, meaning that it relies on other explicit or implicit models which do not contain necessary details. A platform-specific model is a view of a system from the platform-specific viewpoint. A PSM combines the details that specify how the system uses a particular, in other words, the PSM is more detailed version of PIM. platform-specific elements are added. When defining a PSM, a target platform model has to be available. A platform model provides a set of technical concepts representing the different kinds of parts that make up platform and services provided by the platform. It also provides for use in the platform-specific model concept, representing the different kinds of elements to be used in specifying the use of the platform by an application. MD has been profitably implemented in many small and large organizations. While some companies prefer to keep their success a secret to their competitions, many have agreed to publish their accomplishments, as can be seen on the OMG website as well in the various magazine articles. The promise of model-driven architecture is to facilitate the creation of machine-readable models with the goal of long-term flexibility in terms of technology obsolescence. New implementations infrastructure can be more easily integrated and supported by existing designs. In terms of portability, existing functionality can be more rapidly migrated into the new environments and platforms such in dictated by the business needs. In terms of productivity and time to market, by automating many tedious development tasks, architects and developers are freed up to focus their attention on the core logic of the system. In terms of quality, the formal separation of concerns implied by this approach, plus the consistency and reliability of the artifacts produce all contribute to all the enhanced quality of overall system. In terms of integration, the production of integration bridges with legacy and or external system is great facilitated. In terms of maintenance, the availability of design is a machine readable from gives analysts, developers, and testers direct access to the specification of the system, simplifying their maintenance chores. In terms of testing and simulation, models can be directly validated against requirements as well as tested against various infrastructures. They can also be used to stimulate the behavior of the system under design. In terms of return on investment, business are able to extract greater value of their investment in tools. When it comes to the model-driven process, whatever the ultimate target platform may be, the first step when constructing an MDA-based application is to create platform independent model expressed via UML. This general model can be transformed into one or more specific platform such as CCM, EJB, .NET, SOAP, etc. A complex system may consist of many interrelated models organized along well-defined layers of abstractions with mapping defined from one set of models into another. Within this global set of models, horizontal transformation may occur inside the single layer of abstractions, in addition to the typical vertical transformation across layers. Applying a consistent architecture style across viewpoints of the system is one illustration of such a horizontal transformation. Other examples includes with a CIM, create a target model containing all of the business rules defined in the core business model. With an PIM, create a target model containing only the data elements defined in the conceptual model. Within the PSM, Create a target JUnit test model from Java class model. Note also that PSM, one layer of the abstractions, may take on the rule of the PIM with the regards of to the further transformation down into another layer. Beyond the perhaps simplistic notion of CIM, PIM, PSM, the two key concepts of the MDA are models and transformations. The general pattern is source model plus transformation rules is equal to target model. These patterns can be repeatedly applied to successive models, each one playing the role of either is PIM or PSM. So, the first part of MDA process is transformation mapping. MDN mapping provides a specification for how to transform a PIM into a particular PSM. The target platform models determines the nurture of the mapping, while part of the transformation can be resolved from the manual exercise. The intent is clearly to automate as much of the process as allowed by the toolset in use. Let's take the example of mapping which defines annotations called marks in MDA parlance that are to be used for guiding the transformation of UML PIM to EJB PSM. Marking a UML with a stereotype session would result in the creation of session bin and other supporting classes within the PSM. Transformation rules between models can be expressed at the type level from types specified in PIM languages to types expressed using the PSM language. In UML, example of such types referred here include class, attribute, and operation. In accordance to patterns of type usages in the PIM, example, a GOF strategy pattern within PIM can translate into a idiomatic equivalent in PSM. At the meta-model level for transformations that need to bridge model languages, the second process is making models. Generally, type markings are insufficient to specify a complete transformations. Additional rules are required to specify that certain types in PIM must be annotated a specific way in order to produce the desired output in the PSM. This extra information cannot be determined from PIM itself. A mark represents a concept in PSM which is applied to an element of the PIM in order to indicate how that element is to be transformed. Marks being platform specified are considered part of PSM. In multiple PSM scenario, each PSM would use different marks against the same PIM. The PIM plus all the platforms mark constituent the input to the transformation process resulting in a PSM. Implicit or explicit transformation rules exist to indicate which models elements in PIM are suitable for certain marks in the order to generate the desired element in the PSM. The set of marks can be viewed as an overlay or transparency over the PIM for the purpose of transformation. This set can optionally be supplied as part of UML profile. Another option is to associate a set of marks with a template containing the rules according to which instances is a model are to be transformed. The rules can be specified which values in the source model can be used to fill the parameters of the template. Third is mapping languages. A model transformation mapping must be specified using some languages, be it a natural languages or an action language, or indicated mapping language. The OMG is currently in the process of adopting the MOF Specification as portable mapping language. A record of transformation should include a chart indicating which PIM elements were mapped to which PSM and include the mapping rules used for each part of transformations. Fifth, MDA process is the illustration of transformation. The diagram uses UML notation to the present. The various concepts involved an MDA transformation for a given platform. Example, target model. It distinguishes between the abstract view of the platform's transformation directives and a concrete implementation in the context of a specific source model to be transformed into this platform. A further way to organize transformation mapping is via inheritance hierarchy. For example, a mapping to create an RDBMS informations could be specialized for specific database vendors. 6. MDA process is the generation of code and other artifacts. So the final step is transformation process to generate the implementation code as well as perhaps other kinds of supporting artifacts such as configurations files, component descriptor files, deployment files, build scripts, etc. The more fully application semantics and runtime behavior can be included in the PSM. The more complete the generated artifacts can be. Depending on the maturity and quality of MDA toolset, code generation varies from significant to substantial or, in some cases, even complete. Note that even minimal automation simplifies the development work and represents a significant gain because of the use of consistent architecture for managing the platform independent and platform specific aspect of application. After the final MDA process, which generations of the codes and other artifacts is to move forward? Go ahead with the next steps. One is the think of transitions process, moving from a traditional software development approach to one that is model-driven is fully fledged transitions that requires formal planning, orchestrations, and sponsorship. Transitioning an organization to the model-driven approach is a major project that will take time and resources to plan and manage over a period of years. Defining the transition life cycle consists of developing a strategy and a plan for each stage and monitoring the resulting activities. It requires a major ongoing effort, continuing support from IT management. Transition is not a one-time process improvement effort. Rather, it is a transition program that must be formally planned, approved, and founded by management. It must be executed with all the diligence and check marks of a real project. Moving too fast, out of sequence, or proceeding without proper planning simply puts the whole transition process at risk. The main ingredient for ensured success is keeping the end vision of the transition in sight. Second thing to do is to promote tooling. Tooling is an essential part of MDA environment because tool capabilities replace human skill sets. Understanding that the tools will generate most of your project artifacts. It is crucial to establish the right infrastructure for the development environment, along with the indicated team to support it, manage, and continually involved to meet the IT development requirements. The IT organization must carefully evaluate the select the right tools with capabilities to meet the organization's specific requirements. The companion tool specific MDA papers offer guidance and features checklists to consider. Third is all about considering the factors of success. Establish the foundation and equivalent to invest the time and forethought in the analysis phase of transition project. The foundation is manifested as a set of blueprints for your transition and measurement system to track progress. Setting the appropriate expectation is crucial, especially when it comes to keeping early expectation in bounds with the current realities of daily workload. Designing a development environment properly for the model-driven approach is one of the most crucial factors for the success. This is where tooling takes over human grunt work and transformation replace routine skill sets. Plan for pilot projects and don't be tempted to jump into a real project only equipped with notions of how to proceed in the new approach. Try before you buy. A successful pilot can also be turned into real deliverable. Plan for recurrent review and adjust milestones. This is where you put measurement system to work. With no proof of progress, you cannot sustain funding. These are my reference. Once again, thank you for listening and good day, everyone.